Right, now time to hand over to very much the next generation in the sheep genetics team, that's for sure. So I'd like to welcome Emma and James to the floor to run this next session leading through. Hopefully they're both relatively new to the sheep genetics team, so if you haven't met either one or both of these two, make sure you do over the next couple of days. Key to working with you in terms of your day-to-day stuff with your flocks. So James and Emma, the floor is yours.
Thanks, Richard. And do come and make yourself known. I've met a few of you, but still getting around to introduce myself. So this session's designed to update you on some of the more recent projects that have been going on in the sheep genetics space. We have 4 speakers who'll each give the outline of their projects they've been involved with, quite short presentations. So we'll allow for questions at the end. Please text any in and have the number and the numbers in the booklet, and please have the name of the person you're directing the question to. So to kick things off, I'll introduce our first speaker, Dr. Troy Fishcer. Troy and his wife Nett run a seed stock and grain business at Wasleys in the mid-north of South Australia. Their stud Ashmore White Suffix has been involved in land plan for 30 years. And Troy is speaking on behalf of Superwhites, outlining their producer innovation fast track project, which aim to improve the rate of genetic gain in hard-to-measure traits like eating quality and lean meat yield. This project ran for 12 months, finishing in 2018. Producer Innovation Fast Track, or the PIFs, is an initiative developed by the MLA donor company to enable producers to be actively involved in the innovation agenda. Troy will now share the key outcomes from the project.
Thanks, James. Thanks for the opportunity to present to you guys. I've been told I've got 4 minutes, so I'll get straight into it. You all know the title. A little bit about Superwhites. There's 19 of us. We're ram breeders scattered across Australia. Collectively, we market around 3,500 rams each year. I guess as a group, we have common interests in the sense that we progeny test each other's top sires. Roughly the best 10 males out of the whole group are tested each year, progeny tested. We foster strong genetic links between our flocks. We strive for excellent data quality, and all of this sort of wraps up into making rapid gain for traits relevant to industry. In terms of the project, essentially we were looking to improve the rate of progress for meat quality and lean meat yield traits through better accuracy in breeding values for those traits. Why do we want to do that? It's fairly obvious, but essentially the graph that Daniel Brown put up, and no doubt people have been talking about over the past few days, eating quality's steadily been declining, and if we don't do anything, we're going to have wind up with a bit of a problem on our hands. How do we do this? Essentially, we DNA tested roughly the top 30% of all 2017 drop males based on the lamb eating quality index. And so that's sort of the genotyping arm of the project. And then there was a phenotyping arm which was focused on collecting DNA samples, carcass measurements, and meat quality phenotypes on cull females. So fully pedigreed, fully performance recorded cull females out of our flocks. In a nutshell, we collected over 2,000 genotypes on 2017 drop males. We saw a range in accuracy improvement in the breeding values for the eating quality traits of 5 to 10%, which is significant and of benefit. But we also saw increased variation in those breeding values, and I'll show a few graphs in a minute to demonstrate just what happens once the different sources of data went into the analysis. On the phenotyping side of our project, 300 females were slaughtered, cull females. It's not a perfect data set, admittedly. They were ranged across 55 different sires, and so not huge progeny numbers per sire, but where we had, let's say, double figures of progeny per sire, we saw really significant accuracy improvements for these traits, 20 to 25%, which as breeders we got quite excited about as well. And once that data went into the evaluation, we started to see even more variation in those, in the breeding values of those 2017 drop males, which was really about making better selection decisions. We got more information, higher accuracy, more spread. And so going to have to speed up. This is tenderness v marbling breeding values. So tenderness is on the left, so that's the shear force breeding value. Marbling's on the x-axis. And essentially the red line, this bottom, from where you're looking at, right-hand corner is sort of the top 10% animals. So they're good for tenderness and they're good for marbling. So they're tender and marbled. So start of the project, that's where the 5,000 odd males in our group sat for breeding values. We added genotypes and we see a fair bit more spread in those breeding values. We added genotypes and phenotypes and we see a great deal more spread, but I guess also importantly we're seeing lots more animals in that sweet spot, in the top 10% for both traits. But I guess the rubber hits the road in terms of the actual rams that we used. And this is real life, this is not perfect. So you see a cross-section across that spectrum, and essentially that's just demonstrating that we're not just selecting on these two traits, there's lots of other traits in our breeding objective. But I'd like to think the number of red dots, which are size that we used out of that 2017 drop, I think there's 90 of them, they'll progress towards the bottom. So that's in summary. You can read faster than I can talk. And I'd just like to sincerely thank all the people that are involved in this project. 4 minutes, tough gig. Thank you.
Thank you, Troy. We're now joined by Peter Blackwood. Peter and his wife Claire run Blackwood Corriedales near Avondale in Tasmania. They've been performance recording their stud animals since 2006, as well as running a commercial prime lamb operation. Peter is currently managing the Corriedale meat eating trial at Cressy in Tasmania. It's funded with the support of the Davies Research Institute, the University of Adelaide and MDC. Through this project, the Corriedale Performance Group aims to collect progeny phenotypes to develop a reference population for the breed. The project had its first drop of progeny in 2017. I'll now hand over to Peter.
Oh, thanks Emma. Yeah, we do only have a short time, so we'll get straight into it. Look, how'd the Corriedale meat eating genomics trial come about? The members of the Performance Corriedale group had always said one of the strengths of the Corriedale was its eating quality, but this was only anecdotal. We didn't want to lose this advantage by putting pressure on growth, muscle and fat and those traits, and potentially losing these eating qualities without accurate measurement. The aims of the trial was working with sheep genetics. We could measure traits with growth, wool and ewe production, and we've recently worked a new index, the Maternal Wool Production Plus Index, and we also market within the group the top indexes with gold, silver and bronze. But the gaps were the existing work for a smaller breed was always the lower accuracy in lean meat yields and eating quality. Financially, the group could not conduct this trial on its own. We needed supporters. The submitting sire breeders were 15% of the project, University of Adelaide 27%, the MLA Resource Flock 17%, and the donor company 41%. This was the start, but a lot of work was required by the performance group and supporting partners to collect and record data. The trial so far, in 2017 drop, these were slaughtered in April 2018, an average of 19.4 kilos. This was for the complete drop, triplets, twins and singles, to collect as much linked data as we could, and these lambs had live measurements taken throughout their life with fleece weights, live weights, muscle and fat scans. 2018 drop have been weighed, weaning and post-weaning, live structural and wool traits taken, fleece data collected at shearing with expected turn-off date of mid-April 19 at around 21, 22 kilos. And for the 2019 drop, we've got 2 joinings lambing in August and late September to build our numbers. The involvement of the Performance Corriedale group is paramount to the success of this trial through labour at crucial times through AI, lambing, lamb marking, data collection of all the physical traits. Also, we've had support of 2 honours students so far from the University of Adelaide, Hannah Gordon in 2018, who completed her thesis, Sources of Variation in Corriedale Lamb Value, and Sarah Welsh has joined us in 2019 and will be completing a thesis on the trial. The Corriedale lamb carcasses are hanging at Fruistall's at Stawell in Victoria, just waiting to be tested. The initial tests entering the chiller, the hot carcass weight, pH and temperature, and the GR fat score. The carcasses were then chilled overnight and tested again for pH and then into the boning room. The midloin was then removed with eye muscle and fat depth measured. A sample of each loin was then tested for intermuscular fat and shear force. This was done by Hannah Gordon in 2018 with the help of Coordinating Supervisor Professor Wayne Pitchford and their teams. The graph of shear force versus intermuscular fat. There's 2 breeds shown here, not as a formal comparison, but just to show common ranges in each. The shear force, lower value is better, less tough, equals more tender, with the IMF higher is the better. Most of the high shear force in the Corriedale lambs was due to a few smaller lambs that lacked fat cover and so muscle cooled too fast, which is termed cold shortening. And these lambs just up in that group there. So at the end of the first year of trial, we're delighted with the intermuscular fat. We've been up to 10% in Corriedale lambs. You know, we're pushing the boundaries in intermuscular fat, and all this data collected so far is submitted to Sheep Genetics and available through lamb ASBVs. And look, as a group, we'd like to thank all our supporters of the trial. There are too many to mention. And finally, Sheep Genetics for the opportunity to speak at this conference. Thank you.
Thanks, Peter. Our next speaker is Mark Mortimer. Mark is a 3rd-generation farmer from Tullamore in the Central West and manages Centreplus Central Nucleus. His key roles include data capture with electronic tags and the storage, management and analysis of data from Centreplus. Mark represents Merinolink and the UNE DNA Stimulation project, which started in 2018 and aims to deliver tools and knowledge, including genomics, to commercial producers through service providers and ram breeders. This project is producer participant funded, with these funds being matched by the MDC and supported by UNE. Thanks, Mark.
Thank you. So for me, the Genomics Journey started in 2011 with the Sheep CRC and Pilot Project 1 and 2. And after those pilot projects, everyone went away and the number of DNA tests that the industry was doing stagnated. So there was a couple of key things there that were hurting us. One was price, and 2, people weren't sure what they were needing to do with the genomic tests. So we had the opportunity through Merinolink to put in an application to the MDC to stimulate genomic tests and how people could use them. So there's, in the project, there's 70 producers involved in the project. All of them have to do a flock profile test at the start and at the end of the project. We have 29 seed stock producers that represent 9,500 rams, sold 17,000 doses of semen, and they sell to 1,750 clients. Combined, those 2 groups have offered to put up $1.5 million of their own money across the project, and the MDC has matched that. There's also service providers involved in the project, and each seed stock producer must have one, so we're building capacity through the project by having a full ecosystem. There's also researchers involved, so we have a half full-time equivalent researcher dedicated to the project, which is Tom Granley is here. I'm not suggesting you're only half a researcher, Tom, but we get access to half his time. And there's also many organisations involved, so it's a collaboration between Merinolink, Sheep Genetics and UNE, and obviously our MLA have been a great help in bringing all that together. Some of the really beneficial key aspects of the project that I've found is the fact that we get to meet regularly. So it's not just giving you cheap genomic tests, but we've got to come back in, we've got to meet with the researchers, we meet with our service providers. And yesterday, James put forward to us that the Sheep CRC was so successful because of the culture of it. And I find in these meetings that we've been having in part of this project, there's a great culture. The seed stock producers are really open and sharing, and it's we're learning as much from each other as we do from the service providers and the researchers. So it's been a really good collaborative, great effort there. And I'm going to wind up there. So that's our Merinolink DNA stimulus package. So.
Thank you, Mark. As this is our final speaker, it's a timely reminder that you need to be texting through any questions to the number provided, and also try and direct them to a speaker if possible. Our final speaker delivering a project update is Professor Julius Vanderwerff. Julius is a professor in animal breeding and genetics at the University of New England, specialising in research into genetic evaluation, breeding program design, breeding objectives and genomic selection. Today he will update us on the MLA resource flocks, which collect a wide range of data for hard-to-measure traits from sires of many breeds representing the Australian sheep industry. I'll now hand over to Julius.
Thank you, Emma. 5 minutes is pretty short, so try to be quick. So the MLA resource flock project, just a few words about the background. So we know to select animals you need the information, and you can measure the animals and the relatives, but that's usually limited to just a few. You could also use progeny, but that takes a while. So now we have genomic testing, and it allows you to link animals through the DNA test through lots of and thousands of others that gives you a lot more information, and that could help make selection decisions. Now it says there how to select animals for carcass. Well, if you don't measure carcass on your relatives and on yourself, then you could have what you call a reference population or a resource flock. If you measure carcass traits on thousands of other animals with the DNA test linked to your selection candidate, you have a chance to select animals on a breeding value with a reasonable accuracy. So the MLA project is really focused on carcass in first instance, because otherwise we would not have any measurements or phenotypes on IMF and carcass quality and eating quality. But also, and that's a bit the new part of the resource flock project, we don't have a lot of information on reproduction, and even if you did measure reproduction, it takes a while before you have information on an animal, and ram selection is 80% of the genetic gain, and before you know a little bit about a ram, it takes a long time, and it's not very accurate because it's a low heritable trait. So if you have lots of other animals you could link up to with that information, then you can do a lot better job for reproduction. So it's really about setting up reference flocks. We started really doing that already in the sheep genomics project, but those were 4,000 animals measured for lots of traits. And then the sheep information nucleus between 2007 and 2011 delivered us 18,000 lambs measured, 10,000 of those were slaughtered and measured for all the carcass and eating quality traits. And everybody realized that was really the basis of introducing genomic selection in Australia. Without that base, we wouldn't be where we are now. And in the world, we've been really unique to have such a resource to actually be able to select for those new traits that otherwise we couldn't select for. So MLA realized that and funded the MLA resource flock project after the CRC was finished there. And so we've measured 15,000 more lambs and 10,000 more animals for meat traits. And so those are the drops of the lambs. So the last drop was 2018. And now MLA has renewed that project, so we have now funding for another 5 years of MLA resource flock project. And it's not really useless, because we'll see that more data always gives more information. So the new resource flock project is roughly similar to what we do now. We measure per year about 2,000 lambs, so over 5 years 10,000, mostly for meat traits, for growth traits. But what we add now is we also want to measure use for repro traits. And roughly per year, this is what we made. But we also try to use a bit of industry information. So roughly, we have crossbreds. Most of the animals that we produce are crossbreds. And we produce merinos, about 40% of purebred merinos. So that's the sire selection that we do. So those are the rams from the different breeds that we use. It's the major breeds, but we use also quite a bit of smaller breeds just to build up a bit of a reference for those over time. So we use about 150 sires per year. So we mostly measure carcass traits and eating quality traits. We do not measure much wool, and we also do not measure much reproduction. But as I said, in the new project, the plan is to measure reproduction with stud breeders, and we then help them genotype those animals if they provide the phenotypes. So over time, we have already more than 20,000 records for carcass traits, and we have measured 35,000 animals over time. Just to show that this is the accuracy of genomic testing alone if in an animal that's not too related to the reference. And we see there's more data. I'm only adding here 3 years more of reference flock. We have now 6 years more. But you do notice that you get more accurate predictions. So we hope that in 10 years' time, we're going to be way above that 0.4, of course. We also use a reference flock for a lot of research and overlay projects. There's a lot of meat projects that are overlaid on the animals that we have. Different ways to measure meat traits. We have now eating quality, so we're going to eat a lot of those lambs of the last 2 years. So we have a lot more data on actually consumer panel assessment of animals. Just a little thing, like we looked at the heritability of tail length, and we found genetic markers for those traits. G by E is an important, so genetics environment interaction is going to be more and more a topic to look at, I think. And how animals grow and how that affects meat quality so all the data is now available to explore what you can do. And of course, it's a big resource for finding better genetic markers that we have done in the CRC project. Thank you.
Thank you, Julius. I'll now invite all the speakers up onto stage. So the first question is addressed to Troy. What was your summary and the take-home messages for the Superwhite group?
Yeah, I needed another minute to get to that. Well, essentially, we use two sets of tools, genotyping and phenotyping, to drive progress in our project. And we saw them both as beneficial. Andrew Swan actually did some work with our data and proved that the progress that we could make with just genotyping alone was equal to genotyping and phenotyping. So there are different ways you can look at it, but essentially genotyping you do early, it's relatively cheap, you don't have to slaughter any animals, but there's a limit to how much accuracy you can generate on a male to be selected, versus the phenotyping side of things, which is expensive. It slows, increases generation interval and slows progress because you're waiting for that slaughter data. But you are identifying, hopefully, some outstanding size, which we did, that will go on to be semen size and have a huge influence across the group and a breed. So I think that's 3 minutes of summary. Thanks.
So the next one's directed at Peter. What would you recommend other minor breeds do that are looking to collect other traits that can't be measured on farm?
Have an understanding wife so you can come to these things and she looks after the farm. But on a serious note, not that it's not, you have to have a group of people that are like-minded and get together and work together. That's been one of the strengths of the Performance Corriedale group. We've been working together for about 12 years. I don't think we've had an argument within the group. So it's really important that you have like-minded people about to gather up what it is you're wanting to collect in traits for your breed, and then getting the collaborating partners to work with you. I think that's very important, because it is very important for the minor breeds that you're not, well, we are part of the resource flock, but we actually have to do some work ourselves.
So the next question is addressed for Julius. Apart from basing it on breed, how are size selected for the resource flock?
We try to select a diversity of genetic background, so we try to avoid sires of families that have been used already in the past, so that if you test the diversity of resources, you also are able to select from that diversity, and for the long-term breeding program, it's important to keep that in mind.
And finally, Mark. What type of things are the Merinolink stud breeders focusing on, other than genomic testing?
Yeah, so the breeders in the Merinolink project are just focusing on the traits and breeding objectives that they've always had. The overriding goal of the project to get MLA funding is the fact that we have to double the rate of genetic gain across this length of the project. So over that 5-year period, as a group, we have to show that we've doubled our rate of genetic gain based on the index, but the individual studs are still focusing on all of their own key breeding objectives. We're just adding genomics in as a tool to enable them to do what they want to do much faster. So a lot more pedigree, a lot more genomics, a lot more accuracy.
Thank you, Mark. We'll bring it back to Troy. Did phenotyping or genotyping find you any outcross sire for eating quality?
Yeah, I think it most definitely did. You saw in the graphs the spread once we added in the additional data, and so at the start of the project we might have had 10 candidates that were in the top 10% for both traits, and at the end of the project we might have had 70 or 80, so the answer is absolutely.
So I think the question was whether it's zinc, and that's zinc, iron is measured in the resource flock, and DEXA. So definitely DEXA, if it's available, we do want to predict lean meat yield, and so if there's a DEXA, we send our lambs there. We don't do the minerals anymore at the moment. It's partly to save costs, but I can tell you we have planned a strategic discussion with meat scientists and geneticists about what are the key traits that we should keep measuring, and it's a balance between how much money you want to spend and what's going to be important in the future.
Peter, are the Corriedale progeny genotyped, and on what density chip?
Yes, this is one of the most important parts of the trial, to make sure that we do get our progeny genotyped and into the database, and we're using TSUs. They're about to be done in a couple of months when the price comes down further.
For Julius, have the general recommendations re genotyping in studs changed with more reference data?
Not really, I think. There's two things that change over time. The accuracy of predictions are becoming bigger, higher, and the cost of genotyping is becoming lower. So, but still, what we said in the past, like if you genotype the top 20% of males, you get 90% of the benefit versus genotyping everything, but you save 80% of the cost. Is still a useful criteria, but of course, if genotyping becomes cheaper and people want to do parentage testing instead, they do genomic testing, those things have an effect as well. At the end of the day, indeed, the accuracy of selection is important, and if hopefully the reproduction EBVs will be enhanced by genomic data, and that would have a big impact, I think, on the gain for those traits.
Troy, was there any re-ranking of size in and out of the desirable quadrant?
Yes, yep, absolutely. As the theory tells us, and as we saw with the data, as accuracy improves and more data goes in, there will be re-ranking. Pleasingly, some of the really good ones stayed really good, but there's definite movement within that data. And that's the nature of the game, I suppose. Just collecting good quality data, submitting it all, and then making decisions once you've got that in there.
While we're waiting, just to add, if genomic testing becomes more accurate, of course, breeders should more and more select younger rams and shorten generation interval, and they can afford that if the accuracy becomes higher. So that will change in breeding programs, I think.
How far away is genomic reproduction data for merinos?
Well, we'll have a session about it tomorrow. So I think tomorrow we're going to talk about introducing genomic breeding values for reproduction. So hopefully Kim and Danny will do that.
For Julius, genomics alone is still not reaching the threshold accuracy for meat traits? Question mark.
No, I agree. Well, if you find IMF important and you have nothing, I think even 20-30% accuracy is reasonable, because if you can still do something about where you go, but it's much better than 50 or 60%. So I think we have to just build up the database, and that's why the resource flock project is very important.
Yeah, Rodney Watt, it's for Julius. Julius, we know that the EBVs or ASBVs for eating quality are strongly correlated with the production traits, or negatively correlated with the production traits. Now, when I put an animal into the sheep genetics database, I'll get accuracies of about 40% for IMF and shear force based on those correlations. And when I do a DNA test, it adds another 3 or 4 or 5% accuracy to that. How do I justify that costing $35 per test?
Well, I think there's one problem sometimes with EBV accuracy. I can have a reasonable EBV accuracy for, say, reproduction based on the body weight of the sheep. But if I select on it, I just get bigger sheep and I also get a bit more reproduction, but I get bigger sheep. If I have an EBV for reproduction based on reproduction alone, I can actually get more reproductive sheep without getting bigger sheep. So those correlations between breeding values are important as well for where you can go with selection, and it's the same here. If you want to do eating quality but not necessarily a lot more growth, you want to balance it more towards eating quality, have more space to move if the correlations between the EBVs are smaller, and you achieve that by having direct information for the trait rather than basing it on a correlated trait. So it's not easy to see on the accuracy itself, and I realize we need to do more to help people see the differences, and so that's a task for researchers maybe and educators, but one EBV accuracy is not the same as the other. It really depends on the data that's behind that EBV accuracy.
Peter Wynn, Merimbula. Just want to know, this is a question born of naivety, what is blockchain technology? Can someone explain that? The first speaker mentioned it this morning, and I haven't got a clue what it is.
In simple, it's a way of tracking something all the way through, so it's a data link. So say you have an EID on your farm, then that goes into a system, and then that can follow through as the animal, through the meat, through the supply chain as a product, and then when it gets to the shelf, they can scan a barcode and it has the full traceability all the way back through. So it's a technology that can allow that in simple terms.
Might wrap up there. Thank you for our speakers for travelling to Dubbo and presenting on the projects. We'll have a quick morning.